So if we got our formula as stress is force over area, and we looked at the shaft first, if we looked at the cross-sectional area, it's 0.8 times by 0.8, so that'll give us 0.64 meters squared. So that is 0.8 and 0.8. It is not 0.8 meter squared. So we've got the compressive stress equals, and we've got 10 meganewtons divided by 0.64. So that's our force over area, and that will give us 15.6 meganewtons per meter square. So you would have to find a material that can cater for that amount of stress for the force of 10 meganewtons at the top. Again, just try and get yourself familiar with the units. So 1 Newton per millimeter squared, it does equal 1 meganewton per meter squared, and it does equal 1,000 kilonewtons per meter squared. So and then at the base, it's and you've got like a cross section. It's Y. Like the cross section in the shaft is, the compressive stress was X. So the area is 1.5 times by 1.5. And the bearing stress, the compressive stress at that point, again it's our force over area. And again, whenever you're doing calcs as an engineer, you write them out and then you hand them to somebody else to check them. And most commonly the errors is where people are trying to move in between sort of meters and millimeters and kilonewtons and newtons. It's a very common mistake. The force over the area. And when it's talking about the area, you're talking about the cross-sectional area that is coping with the stress. So if we have like a steel plate, this orange one, and then we've got another steel plate, this pink one, and that's been pulled down at 40 kilonewtons. The question is what is the shearing stress of this rivet? That could, like today, that would be a bull. So if we're looking at the area of this, we're looking at YY cross-sectional area, There's some formulas that you're not given, you know, like areas of triangles and area of circles and that. And there's something that you just expected to know. Cross-sectional area. So let's times it by the diameter. Now some books also have, you know, the answer there is 100 pi millimeters squared. So, you know, whether you use pi r squared or pi diameter squared over 4, totally up to you. Some books have like 100 pi to keep it in its purest form. I just, you know, multiply it by 3.14. If you want to stick a 2 in, it'll be a bit more accurate than mine. A lot of times when I show you my answers, if you keep it pure with keeping the pi all the way through, then you'll have a slightly different answer to me. So we got our shearing stress. So we got 40 going down. It's 40 kilonewtons. I will times it by 1000 to put it into newtons, and I'll divide it by my area